Let's quickly learn how to set up a regression model in Python in around 4 minutes. First, let's import our data and define our variables of interest. To do so, I'll use pandas to import a CSV file. We can see that we have a data frame or table that is storing 3 variables, x1, x2, and y. Let's now assign the data to the variables y and x. Y is our dependent variable, and x represents our explanatory factors. Now, before proceeding with estimating a regression model, let's quickly visualize our data, which is one of the most important steps in regression given its many assumptions. Through matplotlib, I am going to initialize a figure, which will be a scatter plot between the variables x1 and y. Here, I am quickly checking that a linear relationship exists between them. Phew, all looks good. Now, I can do the same between x2 and y, and I can also do so for x1 and x2, as I may want to know if these variables are correlated, a key consideration in regression. Now, if I wanted to view all of these scatter plots at once, I can create a scatter plot matrix. The diagonals are a histogram of the distribution for each variable, and the off diagonals are the scatter plots we viewed earlier. This is an incredibly helpful visual when evaluating your data structure and determining a statistical approach. Now, if we feel comfortable, we can proceed with estimating our regression model. There are multiple libraries to do so. For traditional regression, though, I really like using the Python module statsmodels. With statsmodels, if you want to add an intercept term in your model, you will first need to add a column of ones via add constant. Let's now specify a regression model. I'll use OLS, or ordinary least squares, which is the regression model that you will learn about in your intro stats course, and it is the default approach for many commercial tools. Having said that, you can also specify your model with alternative approaches such as weighted least squares or generalized least squares, but let's go with OLS. And we can now fit our model and print a summary table of our estimates. And with that, we can now interpret our model results. We can quickly note the R-squared and other goodness of fit metrics for our model. We can also scroll down to view our coefficient estimates, their standard errors or uncertainties, and their p-values to evaluate statistical significance. There are also all of these other outputs that aim to help us understand if our model conforms to the assumptions of regression. If you don't know what they mean, that is okay. There are in fact a lot of neat visuals that you can create on your own to evaluate your model. For example, many of these statistics evaluate whether your residuals, which are the difference between your model's predicted value of y and their actual values, follow a normal distribution. We can create our own plot of this. Let's extract our residuals and quickly make a histogram plot of them. They look approximately like a bell-shaped curve. You could also check this via probability or quantile plots as discussed in another past video that I'll shamelessly plug here. You may also want to ensure that your residuals are centered around 0 versus x1 and that their dispersion is constant over that range. We can create a scatter plot to check that too. And in short, if you know the assumptions of regression, you can create some pretty neat visuals to quickly diagnose your fit. Now, lastly, let's use our model for prediction. We can print our parameter or coefficient values just to remember what they were. Let's now predict the expected value of y if x1 and x2 took on the values of 3 and 2 respectively by using the predict method. Note that the order of values in this list must align with the order of the regression parameters printed earlier. And there you have it. There were lots of statistical topics mentioned that I'll cover in future videos. Having said that, I've also included a link in the description to the code in this video where I expand on some of these topics. Hopefully this tutorial was helpful, and if it was, don't hesitate to like or share. Thank you.